In this project, we are going to extract top 100 global trending songs on Spotify so that we can get some exciting insight from it. So this is the whole architecture diagram of our project. First of all, we will extract data from Spotify using Spotify API. Then we will create two Lambda functions, one for extraction and second one for transformation. And then we will apply two triggers on both Lambda function to automate the process of extraction and transformation. Then we will load our transform data into Snowflake using Snowpipe. And finally, we can analyze our transform data using ChatGPT if you want. So first go to Spotify developer website and then sign in. But if you don't have account, you can sign up. Then go to dashboard, create an app, and then fill the app name and redirect URI and other options, but that's are optional. And then check the web API and terms and conditions, and then save it. After that, go to settings, and then there you will get your client ID and client secret, and then save it because we will use it further. So now first we will install Spotify library so that we can access the Spotify API using pip command. And then we will import Spotify and Spotify credit credentials so that we can access the data from Spotify. It is basically used for authorization. And we will also import pandas so that we can do transformation related to data frame. Now then we will paste our client ID and client secret that we get from the Spotify app, and so that it is also basically for authentication, and we will put it into client credential manager. Now we will make a SP object of Spotify library and put our Spotify credit manager here. Now this is the playlist link. So this is a URL of the top 100 trending songs globally. Now we will extract an ID from this playlist link, which is playlist URI, which we will use for the transformation. Now we will use the playlist track function to extract the tracks available on this URI and save it into a data variable. Now we can see this is a nested JSON data, and here there are mainly three types of information. Information about the songs, album data, and the data related to the artist. And all this data are mainly contained under item key. So we will mainly focus on the item key. So we can also check the length of the data items, which is 50. Now in under every item key there is a track key, and under every track key there is an album. So this is information about the first album. So we can access the album ID, name, release date, total tracks, external URL, and again external URL is JSON, so we can access the Spotify URL only. Now the above was for the first album only. Similarly, we can access for all album using the for loop and save it into a dictionary named album element, and then finally append all the dictionary into one list named album data. Now album list. Now our album list look like that. Now similarly, we can also do it for the artist data and the song data. Artist data is present in under item key, and then again in the track key, and again then in the value key. So we will use key value in this for loop and extract the data related to it. Similarly, we have done in the album key. Now we will convert our album list into data frame using pandas to get more structured data from it. Now we can view the 5 rows using head function of this. Similarly, we can do it for the artist data and songs data. Now we can also see the detail of it using the info function. We will drop here the duplicacy by considering artist ID as a primary key, and similarly for the album using album ID as a primary key, and as album and artist can be multiple, so we mainly drop here duplicacy in these cases. We have not dropped duplicacy in songs data, but if we want we can. Now we have detected an outlier in our data, which we have resolved using replace function. Now here we have convert the data type of data into date time so that we can query in future if we want related to the date. So now in this way we get from the unstructured data to structured data. Now we will go to AWS Amazon console and we'll sign up if you don't have an account, but if you already have, you can directly sign in by giving a mail ID and password. Now this screen will appear of AWS console. Now we will go to the services and type S3. So S3 is basically a blob storage where we can store our files. So here we are going to store our CSV and JSON file. So here we will click on the create bucket, and we can choose the AWS region which is whichever nearest to you, and we will type the bucket name. The bucket name should be unique, so we can append our name to make it unique, and rest are by default, and click on the create. So basically we are going to create two buckets now. First is raw data and another one is transformed data. So in raw data we will have again another two folder, and in first folder is to processed, and another one is processed which contain the processed data after transformation. And in transformed folder we will again have three folders named album data, artist data and song data, which will contain transformed data of album, artist and song respectively. Now we are going to create Lambda function. So Lambda basically a serverless computing services where we are going to deploy our code, Python code for transformation. So we will create two functions named Spotify data extract function and Spotify transformation load function. So the first function is basically doing extracting the data from the Spotify and put it into the S3 bucket into folder named raw data into JSON file format. And for this we have used Boto3 to communicate with the S3 bucket, and after that we put all the data, like dump all the data into that raw data folder, and all our code is remain same which we have already written in Jupyter column. Now in the next Lambda function we are basically we are going to do transformation, and we will store all our transformed data into the respective folder of album data, artist data and songs data under the transformed folder into the S3 bucket. So for that we will use the already written Python code, and also here we will delete all the processed file from the raw data and move into the processed folder of this bucket. Now we will create two triggers, first on the first Lambda function, another one on the second Lambda function. The first trigger is basically a event cloud watch. So it will run at every day. So we will set it for every minute, for every day, for every month, whichever we want. So what it will do, for at each minute or one day, it will extract the data of top 100 trending songs at each date, and then it will trigger the Lambda function, and then all that data all will be available in that our S3 bucket. Now we will apply a second trigger on the another Lambda function. So here what will happen that whenever there will be data available at, in the raw data folder of that S3 bucket, then it will trigger the another Lambda function which will transform all the data present in the raw data and move it into the respective folder album, artist and song, and it will delete that file from the raw data and move it into the transformator. So basically whatever we have done till now in the AWS of extracting data from Spotify and then apply transformation and then save back to their respective folder of transformation. So this trigger will automate this whole process. So now it will automate all process at every minute. Now we will go to the Snowflake site and sign in if we have account. If we don't have, we can sign up. Now we will create a new worksheet and we'll create a new database. And in that, first we will create a storage integration to sync between the AWS and the Snowflake. For that we will use the ARN or external ID. After that we will create a file format, CSV file format, because we are going to use in this code further. Now we will create a three table name: album table, artist table and song table. So whatever data we have processed and saved into the transform folder into the S3 bucket, now all the data will be synced into this table. So that's why we are creating these three tables. After that we will create a stage to sync between that S3 bucket and the Snowflake, and after that we will copy the data from the album, artist and song which has a transformed data from the S3 bucket. It will copy into these tables. So why we are doing this? Because we can query our table and we can analyze more about the data. After that we will create a three Snowpipes, one for the album, artist and another one for the song, so that it will automate the process of transforming the data from S3 bucket into this table. Now we will check our table using the select star query, and after every minute or day, whatever time period we have set in our trigger, all the rows in this table will be updated automatically.